Welcome to Fraser and Dieter's Culture of Compliance podcast series, where we discuss compliance as a competitive advantage in today's marketplace. I'm Sabrina Serafin, partner and national leader of Fraser and Dieter's process, risk, and governance practice. Today, we're talking to Christian Focacci. He's the vice president of offering management with Steele Global. Christian started his career in anti-money laundering, counter-terrorist financing, and compliance sanctions for financial institutions. From there, he moved into developing machine learning tools to support this anti-money laundering effort. And he works with large, mid-sized, and small banks, national broker-dealers, hedge funds, financial technology companies, and some government agencies. Christian, welcome to our podcast.
Hi, Sabrina. Happy to be here.
Today, we asked you to join us to talk about artificial intelligence. People have been using the term AI for decades, but we really wanted to start by talking about how machine learning or artificial intelligence has come to be such a big part of our environment today.
Yeah, so the thing that has changed recently in the last 15, 20 years is the amount of data that surrounds us, and mostly from the internet and internet-connected devices. There's an incredible amount of information that is continually being created. And when you have such a large volume of information, you need different tools and techniques to process it. And machine learning and artificial intelligence is really designed perfectly for that use case, taking large volumes of information, refining it, and deriving insights out of it. And I kind of use the terms interchangeably, AI and machine learning, and you hear a lot of that, especially from the marketing perspective. Every tool and application we see uses AI or they say AI. But the differentiator, the distinction between the two is AI is really the umbrella term for the field of computer science that is trying to create intelligent machines that think, right? And there's a lot of different paths to do that. Machine learning is the most prevalent one today. So when we talk about machine learning or AI, we're really talking about machine learning, but there's other paths to get to that intelligent type machines. And that could be natural language processing, which is taking human text and analyzing it. Image recognition is a type of artificial intelligence, but most of the advances recently have been through machine learning.
You've mentioned a number of different types of AI. Can you give us an idea specifically around how machine learning works?
So when you think about machine learning, it's really the idea of taking large volumes of data and identifying patterns in that data to make future predictions. That's essentially the core element of machine learning. And the way it's done today is there's two types, or two primary types. One is supervised machine learning, and the other is unsupervised machine learning. So for supervised machine learning, the idea is you take a set of data that's labeled. And what that means is you have a set of information and you label what each piece of information is. The common example and one of the first applications of this type of machine learning was to do spam classification for email, right? Nobody likes getting spam emails in their inbox. They're privacy risk, they're cyber risk, and they're just kind of annoying. So one of the first use cases was taking machine learning and trying to solve this problem. And the way the early spam filters did it was you basically took a large number of emails and you had humans hand label what each email was. So this first email was a spam email, this next email was a business email, and you went through this process for thousands and thousands of emails. Once you have that labeled training data set, you can then take a machine learning or supervised machine learning algorithm, there's a lot of different ones, and put this labeled data set through these algorithms, and then it identifies, okay, a spam email looks like this. It has these words, it has these phrases, it has this structure. So pull out features of these emails that are all common, the patterns that are in spam emails versus non-spam emails, and then it'll make a prediction. So that in the future, when you put a new email into this algorithm that it never saw before, it wasn't in that training data set, it knows to say, okay, I've seen emails like this, and this looks like a spam email. So supervised machine learning is really identifying patterns from the past, right? So things it's seen and it's going to predict a pattern. It works very well. There's some risks in it, and one of the risks that is emerging and we're seeing more is different biases. in training data sets. So what that means is if we're training an algorithm to predict things based on information it saw in the past, if the information it saw in the past has some inherent bias, whether systemic or just it's the type of information, that will be reflected in future decisions it makes. Because it's saying, I've seen this before and this is how we've handled this in the past. So in the future, we're going to make this decision, but that might not be the best decision. So it's really a new field because there's a lot of ethical concerns about how we're applying these algorithms. And we are not 100% sure of what the right thing to do is. So there's the technical piece of it. Can you train a classifier to make decisions and use machine learning? And the answer is yes, we absolutely could do that. Then there's this whole other, ethical side of it of should we be doing it? How should we be applying it? In what cases is it relevant? Because that's now where we're at, where we're dealing with these decisions from once we solve the tech piece, there's the real world implication piece. And that's so early on that everyone's trying to grapple with these concepts today and trying to figure out what's the best way to apply this and in what situations it's appropriate.
So you mentioned unsupervised. What is the difference?
So unsupervised learning is there is no training data set like supervised. So unsupervised is you have a set of information. So, for in that spam email example, say you have these 1,000 emails, you would put them through an unsupervised machine learning algorithm. And what it does is then it just identifies patterns and groups them together or clusters them, but it doesn't say what each of these patterns is. So there's an additional step. So basically we'll take all the data, you'll run it through an unsupervised machine learning algorithm, and then it'll put an output and it'll say, these 10 emails are in this bucket 1, these 20 emails are in bucket 2, based on some element that they're all similar. So then there's an additional step where then you have to look at these buckets and say, oh, bucket 1 looks like spam emails, bucket 2 looks like business emails. So the core differentiator between the two is supervised learning, you have a trained data set that's labeled that you're making predictions off of. And then the computer will make a prediction that matches that. It says, we've seen this in the past, it looks like this is what I think it is. Unsupervised, it's not making a specific prediction, it's clustering information together because there's no training data set. It's saying, I've never seen any of these, and I'm just going to tell you what's similar about each of these different pieces of information. It's really good for taking large volumes of information and clustering it into different buckets. One of the common use cases we see today is fraud detection, where you can do financial transaction monitoring and things like that, and you put them through these classifiers and they'll group things together and they say, oh, all of these transactions are similar, and you can identify this is the pattern of fraudulent transaction. They'll find it throughout. But the core differentiator is the availability of a training data set. Supervised machine learning has training data, unsupervised does not.
If we can talk about some practical applications, we often hear from executive teams, we hear from board of directors that they're looking for their organizations to adopt artificial intelligence. They want them to develop bots. The terminology varies, but it really boils down to an interest in adopting more sophisticated tools to drive efficiency. Can you share your perspective on what makes sense in terms of starting to use artificial intelligence beyond the buzzwords and making people understand what it is that we're really asking for?
Yeah, I'm seeing a lot of the same things as well. And that is partially because companies don't want to get left behind, right? Everyone is seeing this growing in the world, and the boards of directors and senior level management is saying, hey, this is something that might be important. Are we doing it? Are we up to date? So it's a really common trend we're seeing among a lot of companies. And the way I best describe these companies to start leveraging machine learning and AI in their application is to do it in small chunks. Because it's not the core competency of the majority of businesses, right? Most companies are not heavily technology focused with teams of data scientists who are going to be mining information and building classifiers to make decisions, right? That's a very small number of really tech-focused companies. So the best way to start leveraging machine learning today is really through products and services that you're using. So every vendor is saying, we have some level of AI in our application, right? The truth is a lot of that is marketing hype, but sometimes it's not. So the best way to do it is to say, let's look at our processes. Let's look at some of the tools we're using. Are they using AI, machine learning? How are they using it? If they're not, let's ask questions about it. Because then you get the byproduct. That company's core competency is technology a lot of times. They've done all the legwork. And then you can learn through them and see what works or not works. And that's like, there's much lower level of risk. Because if you're going to deploy some sort of new automation process in your workflow and develop machine learning, that takes multiple years and lots of data to do. And it's high risk, right? You can go through this technology project and then 4 years later, you realize, well, we wasted all this time and money and it didn't work, right? And that's not uncommon. So the best way is to say, how are we leveraging it today? Kind of do an inventory in your existing services that you're offering. I'm sure a lot of them are saying they're using machine learning. So dig into that, ask them questions, and vendors are happy to answer that. They'll tell you how they're using it, what works and what not, and what doesn't, because there's a good chance to solve that core initial problem from the question you asked about where boards are going to management saying, how are we using machine learning? That's a direct way to solve it, right? You can say, today we're leveraging these 10 providers for, this HR function or this vendor management function or whatever it is, and they're using AI in this aspect, and we're leveraging it to that. So that kind of solves that initial problem where you can say, hey, we actually are using it today in these 10 different functions. The next step of that is then really digging into how they're using it, seeing what works and doesn't work, and then you can kind of grow from there. But that's kind of the best way to do it because you get the byproduct of that company's technology and research, and there's a good chance you're already using it, AI in some capacity, so you can solve the problem of letting people know, hey, we're not getting left behind. We're benefiting it from our vendors or from our third-party providers.
You did some great teasing. Can you give us some actual examples of scenarios that might be ideal for an initial use for an AI tool and to provide people the answer to those questions when posed?
So when you think of a really good use case or application for AI is to think of any task that's a highly repetitious task that humans are doing on a frequent basis. And those are really the prime areas to apply machine learning. So something that humans are doing over and over again, that's relatively simple. So in my world, a specific example is really, we do research to identify risk information for financial institutions, right? When you go into a bank, they want to make sure they're not doing business with money launderers or terrorist financing or things like that. So a lot of that involves doing research, right? They read news articles, they do check government watch lists and sanctions lists. So it's all this data that's floating in the world, and it's manual. You'll have an investigator who goes and they'll search manually these 10 different sources and read all of these news articles and do this. So a perfect case for machine learning, and specifically how I've applied in the past, is to aggregate public information, so news articles, different structured sources, and pull that together in one spot. And then you can use computers, just like in that spam example, to determine the relevance of different pieces of text. So it could be spam, but it could be any type of information that you're looking to find. If you're a PR firm, you might want to find information about your clients and things like that. If you're a financial risk compliance firm, you might want to find adverse media about a customer or a potential partner or things like that. Is there any news articles? And it's the same process. You take unstructured text or news, you develop a training set of the type of information you want to find, you put it through these filters, and then you get an output. So anytime it involves any type task where humans are reading a lot of the same articles and making kind of simple, fast predictions, that's really the prime use case for machine learning today. But my rule of thumb, and I stole it from someone else, actually my rule of thumb, is that any task that a human could do in like 1 to 3 seconds, a computer could do today. And it really helps not to overpromise what AI delivers today. So just think about, like, you can read an email and you would know very quickly if this is spam, right? Okay, you could tell by subject line and all those things. If you can't do that in 1 to 3 seconds, a computer might not be able to do it today. It's not that great category. So when you're kind of looking through the tasks that you're doing or want to save time, your best bet is to say, what are tasks we have humans doing that in 1 to 3 seconds a human could do this task? And that's pretty much the current state of machine learning today. Machines are very good at organizing that set of information, right? They can see a picture and say, this is a cat, this is a dog. Humans could do that very quickly. So that's where we're at. When you start getting, past that, where you have to read articles and make decisions and use all the good things humans are good at, discretionary judgment in gray areas, computers are still nowhere close to that. But those simple tasks are what they're very good at.
I like that discretionary judgment. That is what computers have not developed to this date so far. So for those who are not computer scientists, are there any key pieces of advice that you could offer for us that are considering adding AI tools to their toolkit over the next year?
Yeah, and that's that really rough framework, that 1 to 3 second decision that humans could do the task or can't do the task. That's really the best guidepost for non-technical people, especially when you're trying to determine if a machine learning application is overpromising, right? So when you look at this and you see this thing, you say, well, I couldn't do that in an hour looking at this news article. I couldn't figure that out. There's no machine that's going to do that, right? And the other thing is, you have to think about if the task is even possible, right? Because a lot of times we see these promises where the task is impossible even for a human. So if a human can't do it, machine level intelligence is not anywhere near human level intelligence. So a machine is not going to be able to do it. Machines can aggregate a lot of information very quickly and do individual tasks very quickly, but more complex things they're not good at. So the perfect example is, a political election. If you were going to say, I'm going to train a machine learning algorithm that's going to pick the winner of the next presidential election, that's impossible, right? They could pick it, a human could pick it, but there's not really any validity in that answer because it's unknowable today. So a lot of times, one, can the task be done very quickly? And that's a good gauge. And then the other is just kind of a gut check. Is this even possible for anything to predict? And a lot of times, without it knowing any pieces of technology, you go, there's too many variables involved and it's impossible to know what's going to happen. So that's not something machine learning or AI is ever going to do, right? And that's kind of how I bucket those two things. One, is it possible very quickly? And two, is it just possible in general? And it doesn't, and that's, humans are pretty good at kind of having that gut check and figuring out that doesn't smell right? That doesn't seem possible.
Christian, thank you for being with us today and sharing your insights with our listeners.
Oh, thank you, Sabrina. I was happy to be here.
And to our audience, thank you for listening to Fraser and Dieter's Culture of Compliance podcast. And please join us for our next episode as we continue to discuss transforming compliance requirements into investments in your business.
Thanks for listening to one of Fraser and Dieter's branded podcasts. To learn more, connect with us on LinkedIn or visit us at FraserDieter.com and be sure to subscribe so you never miss an episode.